Hey, welcome back. So we're moving on to the third of our elementary sorting algorithms, the last one for this section, before we move on to some of the scarier ones, some of the fancier ones. Let's call it fancy instead of scary. So insertion sort, actually, it's pretty similar to bubble sort and to selection sort. We grouped them all together. However, there are a couple of key distinctions, some things that insertion sort is actually good at. So this isn't one that's just good to know about. It's not just a good challenge. There are situations where insertion sort does well, and I'll explain that as we go. But first, let's talk about how it works. So it builds up the sort by gradually creating a larger half of the array, which is always sorted. So instead of finding like the largest element at a time or finding the smallest element at a time, it takes each element and places it where it should go in the sorted half. So let's take a look. That doesn't really mean much, but if this is our initial state, we start with this. Our sorted half of the array is shown in green. So right now, half is not the right term, by the way, the sorted portion of the array. And our value we're looking at is 3. So where would we put 3 in order to sort this part? Well, we'd put it before 5, right? We insert it into the right place. Now we hit 4. Where does 4 go? We insert it between the 2. So now this is our sorted portion. Then we hit 1. Where should we put that? At the beginning. And we hit 2. Where do we insert that? Right there, index of 1. So you can see what happens is that we gradually build up the sorted portion of the array by inserting one item at a time in the correct place. So here's a quick walkthrough of it. If we start with this small array, we have 3, and we take 44, and we figure out where it should go in our sorted portion. Well, actually, it just goes right back where it was because it's greater than 3. That's where it belongs. But now we get to 38. Where should we put 38 in this left portion? We put it between the 2, like that. Then 5. Where should that go? Well, it doesn't go there, does it? Nope. So we have to check the next one. Does it go there? Yes. In between the 2. 47. Compare it to 44. Oh, you just go right where you are. 15. Compare it to 47. Nope. Compare it to 44. No. Compare it to 38. No. Compare it to 5. Yes. And now we have the sorted array. So hopefully you can see why it's called insertion sort. We are taking an element one at a time and inserting it in the correct spot. So as far as the pseudocode, what you do, you start by picking the second element in the array because our sorted portion will be considered the first element at the very beginning. So we don't need to sort the first element. So we take the second one and we compare it to the one before it, and if necessary, we swap them. Then we continue to the next element and check if it's in the correct spot. So we iterate through the sorted portion, the left, at this point, if we've sorted 2 of them, the left 2, and we figure out where to put the third one. And we repeat until the array is sorted, and then return that array.